I hope you're having a good day, and thank you for studying your math with me. Today's topic is rational expressions, and we'll talk about adding, subtracting, multiplying, dividing these rational expressions. The first thing we're going to talk a little bit about is the domain, and the question is, find the domain of this rational expression. Now the deal is you can't have a zero in the denominator, so it can be any real number except x being minus 3 or x being 1. So the answer would be all real numbers, x not equal to minus 3 and x not equal to 1, and again the denominator cannot be 0. Additionally, I asked the question, for what values is this expression equal to 0? Well, it's going to be equal to 0 when the numerator is equal to 0 and the denominator is not equal to 0. So the numerator is going to be equal to 0 when x is equal to 7 or x is equal to 1, but the denominator is also equal to that, and we would have 0 or 0. So the real answer to this question is only x equals 7. That is, this expression is equal to 0 when the numerator is 0 and the denominator does not equal to 0. And note that 0 over 0 is undefined. Now the next example is talking about rational expressions in lowest terms. That means what we need to do is we need to seek to identify any common factors in the numerator and denominator, and we will cancel them. And so what we do is we will factor the numerator, we'll factor out the common factor of 6x, and we'll factor the denominator into 2x plus 5 and 2x minus 5, and we will seek to cancel common factors. So we will factor the numerator this way, the denominator this way, and we will cancel these factors. And you can cancel those as long as x doesn't equal 5 halves. Otherwise you would have 0 over 0. So the final answer is 6x over 2x plus 5. We will do the same thing with this one. Again, we will factor everything. We will factor the numerator and the denominator. The numerator will factor into x minus 4 squared, and the denominator will factor into, we'll factor 2x out of that, and times 4 minus x. And so for x does not equal to 4, we can cancel x minus 4 with 4 minus x. Now when I cancel those are negatives of each other, so I will get a minus in front. And so what I can do is I can factor, and I just wrote the minus out there in front, so it's minus x minus 4 over 2x. Note that when you have a fraction, you can put the minus out in front, you can park the minus in the numerator, or you can put the minus in the denominator. They all mean the same thing. When we multiply rational expressions, we'll multiply across the top and across the bottom, but we be alert for common factors. And we will cancel common factors one with another. So here, what will happen is I will cancel 7 goes into 7 once, 7 goes into 28 4 times, and 3 goes into 6 twice, 3 goes into 9 3 times. And then I have z to the 6 over z squared. That's going to be a net of z to the 4th. So what I'm going to have then is 2z to the 4th after I cancel that times 4, and the only thing that's left in the bottom then is the 3, so it's 8 over 3 z to the 4th. Again, when we're multiplying, we're going to multiply across the top and across the bottom, but we'll be alert for common factors and seek to cancel those, which means we're going to have to factor these things like we discussed earlier. So whenever we factor those and multiply across, we have this expression. We have this times this, but there are things that can be canceled. This goes into this once, goes into that once. I also have a, let's see, n plus 2 over n plus 2. Having canceled all those, what I'm going to do is I'm going to get 4n minus 5 all over n plus 4, provided you don't have a 0 in the denominator for any of those things that you canceled. Now we're going to talk about dividing. When you divide, you invert or take the reciprocal of the divisor, which is this one, and then you multiply across the top and across the bottom. So we'll do that. We'll also factor all of these expressions. So if you factor 5z squared minus 16z plus 3, and you factor all of these things completely, you'll get this expression. So we factor the numerator this way, the numerator this way. We invert, so this numerator is now in the denominator being factored this way, and the 2z cubed plus 8z squared is being factored up here. Now we will seek to cancel common factors. So we'll cancel that with that. We'll cancel this with that. And we will cancel this with that. And so what is left at the end of the, and we will cancel this with that. So at the end, then we will have z squared over z, which is just going to be z. Now, so the answer is going to just be, the only thing that is left is z over 3, provided none of the things that we canceled were 0 over, giving us 0 over 0. So x can't be 3, x can't be minus 4, x can't be 0, and x can't be 1/5. Here again, now we're multiplying across the top and across the bottom. We're going to be doing group factoring over here, something we've studied before. Here we're going to have the difference of squares. Here we have the difference of cubes, perfect cubes. This is a very significant factoring problem. But we factor everything and we end up with these expressions. The numerator factors this way, the denominator factors this way, this numerator factors this way, the denominator factors that way. So now we can cancel common factors. That will cancel with that. This one will cancel with this one, and this one will cancel with that one. So at the end of the problem we will have left x minus 2 over x squared plus x plus 1. And provided that nothing that we canceled makes the denominator equal to 0. So any of the factors that we cancel, top and bottom, we can't have 0 over 0. Now we're going to talk about adding and subtracting. Whenever we add or subtract, we need a common denominator. The least common denominator is the best one, so when we look at this, the least common denominator is going to be 30z to the 4th. So I have to multiply top and bottom by something that will give me 30z to the 4th. That means I multiply top and bottom by 3. That gives me a 9. Here I have to multiply top and bottom by 2z squared. So the least common denominator then is 30z to the 4th. I do the multiplications like I did. Now I have a common denominator, so I can add the numerators over the denominators, and that's the answer. 4z squared plus 9 all over 30z to the 4th. Another example, we have this expression, and you should note that this denominator is minus 1 times the other denominator. So if I take my least common denominator to be m minus 5, then what I get is, this is already m minus 5, and I will take the negative here and put it in front, and so I will have 7 over m minus 5 minus 2m over m minus 5. So I have 7 minus 2m over m minus 5, and that's my answer to that problem. This one's a little bit more involved. What I'm going to be doing is subtracting these. I need the common denominator. The least common denominator must have all of these factors. So I'm going to have a factor of x minus 3, x plus 5, and x minus 5. So here I'm going to be multiplying top and bottom by x minus 5. Here I'm going to multiply top and bottom by x minus 3. That's what I'm going to do with that least common denominator. And I'll have this expression all over the least common denominator. I will simplify the numerator by distributing this, and I will end up with 4x minus 20 minus 6x plus 18. So this is what that simplifies to, and when I simplify that, I'm going to get minus 2x minus 2 all over that common denominator. And I could pull the negative out in front, and I could choose to write it like this. These are called complex fractions. There's a number of different ways you can do this, but probably the simplest way is to multiply top and bottom by something that will clear the denominators. Here, the only denominator that you see is x squared, so I'm going to multiply by x squared over x squared, simply multiplying by 1 and seeing what I get. So here I take the expressions, I multiply by x squared over x squared. When I multiply 3 times x squared, I get 3x squared. When I multiply 4 over x squared times x squared, I just get 4. Similar down here, I get 6x squared minus 1. That's the answer. I'm going to employ the same construct here, except here I'm going to have to multiply by a z to get rid of this one, a z plus 1 to get rid of that one, and a z minus 1. So I'm going to be multiplying top and bottom by z times z minus 1 times z plus 1. So let's do that. So I'm multiplying by 1, the z plus 1, z minus 1, z plus 1, z minus 1. So I start distributing. Here, when I take this times this, I'm left with z times z minus 1. When I take this one times this one, the z minus 1 cancels, so I'm left with z times z plus 1, and the minus is in the middle. Down here, when I take this times that, the z will cancel. I'm left with z plus 1 times z minus 1, or this could be written as z squared minus 1. When I take this expression times that one in the denominator, I'm left with z times z minus 1. Now I will distribute here, getting z squared minus z, and here I get minus z squared minus z. The z squareds will cancel one with another, and I'm left with minus 2z over 2z plus 1 times z minus 1. I could have left that in a non-factored way, but I factored it just to make sure that there was nothing that was being canceled. So that's the way it is with rational expressions, adding, subtracting, multiplying, dividing them. Until next time, please take care and remember that time is precious. Each day must count. Do the math. It will make you strong.